Okay, now on to the second part of Help and Tips Part 1. I hit my 15-minute mark before, so let's try and keep the rest of this under 15. Maybe I can get to the second tips file. In any event, we started to inspect our data. We've got the view command to just look at our data. We can use head and tail commands to look at the first rows in our data and the last rows in our data. There's a really powerful command called str. And to use it, you do str parentheses name of your data frame and end parentheses. And I'm going to do Control Enter. Here's what str gives us. It basically gives us a cheat sheet on our data frame and tells us every little thing about it. Think of it like the owner's manual of your car. This is like the owner's manual for your data frame. And before you use your car, it's generally a good idea to read the owner's manual. Just like before you use your data, it's a good idea to look at the string function. I call it the string function, str. Use the str function to look at your data before you do anything. What you want to do is, this says right off the top, 30 observations of 29 variables. Now, you don't know these data yet, so you don't know if that's accurate or not. But many times when you collect data, you know how many observations you have. You know how many variables you have. And so you can check right away. Do I have 30 observations and 29 variables? Yes. Then what comes after is every single variable, its name, the variable type that it is, and then the first few observations for that variable. So there's some things to point out. Again, one, the first column here is just all variable names. And since these are NBA data for basketball, these are different basketball statistics for the most part. So I've got blocks, I've got steals, I've got total rebounds, stuff like that. There are different variable types, and you see most of them in this data set actually. And so let's just quickly hit on those. INT stands for integer. An integer data type is a number that does not have a decimal point to it. So, for example, G stands for the number of games played. That is an integer. 82, 82, 82, 82. Great. NUM stands for numeric. That is a number that has decimals to it. So for this field goal dot, I think that's a field goal percentage. So that's going to be a proportion here. So that's going to have decimals, 0.466, 0.43, 0.443. So that's what numeric types are. Then I have this thing called a factor. And if you remember when we did the import data set, it said to do strings as factors. Well, here's what happened. R looked at it and it said, hey, I've got letters here. I've got characters. I don't have numbers. So should I call that a string or should I call that a factor? Because R treats a string differently than a factor. And you don't need to worry too much about that now, but they're two different data types. So it made everything that is a character, so a team name, for instance, it calls those a factor. And it says there are 30 levels of this factor, which should make sense because there are 30 different team names. So here is another example of a factor. And sorry, I'm just going to make some space here to pull this up from the bottom. Another factor in this data set is this CONF. That stands for the conference in which each team plays. And it can either be an E or it can be a W. And those are just letters. Those are not numbers. Well, we told it to treat strings or letters as factors. So R thinks, great, I've got a factor variable, and it has two levels, E and W. And numerically, it codes it as a 1 or a 2. You don't need to worry about that. In any event, This str function I cannot recommend enough to look at before you do anything, just to make sure you have the variables that you expect, you understand what the variable types are, you agree with observations and the number of variables. It's just doing good data management. So that's sort of some of the initial inspection of data. Moving on are a handful of things we're not really going to use that much, but I just want to show you that they're here. And you can go back and read these on your own, but I'm not really going to have you do much with this. I just wanted to give you the basics. Section 5 here is about finding missing data. In real data sets, there's a major problem with there being missing data, whether it be the person collecting the data forgot to enter something, or whether there actually aren't data there at all. You might have, say, an education intervention in a school district, and you had 30 kids at the start of your study, and maybe you only have 25 kids who followed up at the end of your study. And suddenly your initial data frame, which had 30 students in it, maybe only has 25 test scores, and that would count as missing data. We won't deal with missing data in this class, but I think it's still useful that you know how to find it. So I can tell you that there are no missing data in this data set, and you're going to see why. In general, just to look at if there's missing data, you can do this command is.na. NA is R's way of saying missing data. So it's saying, are there any NAs in it? And I can do that. What it does is it spits back every single column, every single cell in this data set. And the word false means that there is a value there. So there's a value all throughout here. I won't do it now, but if there actually were missing data, let's say that the first team was not listed for some reason, then that would say true instead of false. I can also look for missing data within one variable. So let's say I want to look to see if all teams were listed. I can use is.na, and then I can do the name of the data set. And then here's a thing you're going to use over and over and over again, the $sign. The $sign allows you to fetch a specific variable within your data set. So I can say, hey, I want to look for whether or not there are missing data in the team variable. So I'm going to do NBA 15, $sign, and then the name of the team variable, which is team. It spits back a bunch of falses because all the teams are there. I could look at a different variable to see if that has missing data. And I can do is.na, type the name of the variable in, and $sign. And the neat thing is, when you type in $sign, RStudio is smart enough, it gives you the list of variables in your data set. So I want to say, are there any missing data for the free throw variable in my NBA data set? And nope, all the data are there. And I'm just going to quick skim by this because I'm not going to have you do this, but it's here. If you want to look at how much data are missing, you can run this thing is.na, the name of the data set, and you could set it equal to something, and you can say, I want to call this missing NBA. Great, so now I've created a thing, we call it an object called missing NBA, and that stores the results of whether or not there are missing data. And I can then just use the table command on this thing called missing data, and it says there are 870 cells that are false. In other words, all 870 cells of our data set actually have data. Great. Okay, just a few more things here. So if you remember from before, I'm going to scroll up to when we did the str function, and we went through this thing about variable types. you can change these variable types. R tries to do its best guess for what the variable type is. But maybe you want to change a variable type. So what you do is, and I've listed all the examples here, but I'll sort of type it out live for you. Let's say I want to take the field goals made variable, and it's currently an integer. And let's say I want to make it numeric, a .num. Well, to do that, I just simply list the name of my data frame, NBA 15. I do $sign to pull it up, and I specify the name of the variable, field goals, and then I simply type as dot. And the as dot, what that does is it allows me to then say what variable type do I want to change this into. So if I want to change it to numeric, then I'll say as dot numeric. And what am I changing in the first place? Well, I'm changing the field goal variable from NBA 15. Great. Okay, so I've said as dot numeric for this field goal variable. Let's check it and scroll up. And sure enough, the field goal variable is now numeric. And you can change it into any type, as factor, as character, as numeric, or now I'm going to put it back to an integer. This shouldn't be too big of a deal right now, but it may be a bigger deal later on this semester. So for just the last couple minutes of this video for Help and Tips Part 1, yeah, this is definitely going to be the longest video, I think, out of all these. This is a two-parter. You can pull out very specific things from your data set. I'm never going to have you pull out things from your data set, but it's here if you need to. So for example, if I look at the data momentarily and I see teams and I've got this variable pts.g, that's points per game. That's how many points per game on average each team is scoring during this season. Well, you can see I have 102.5 and 98 and 98.5. Well, let's just say I wanted to ask, well, how many teams do I have that scored above 100 points per game? Because I've got some above and I've got some below. Maybe I want to track how many teams I have that are scoring above 100 points per game. So I can use this table function, which does many things, and here's one of them. And then, like we've seen before, I type in the name of my data frame, $sign, the variable I care about, points per game, and then I specify the exact condition I want. So points per game greater than sign, greater than 100, and I can do Control Enter on that. And it says, great, there's 15 that are above 100 points per game. That's what the true means. And there are 15 below 100 points per game. That's what false means. And I can also turn that into a data set. And what you do is you specify the new name of your data set. I'm going to call it NBA.100. And then I use the subset command. And what the subset command does is it says, give me my original data, NBA 15. Give me the condition that I want to pull from my original data. And then make that a new data frame. So again, name of my data set, the condition I want to make the new data frame, teams with over 100 points per game, and finally the name of the new data frame. So I can run that. And that gives me NBA.100, and it gives me 15 teams. Finally, in the last 20 seconds here, you can combine variables into whatever you want. You can use mathematical operations on them, and like if I want to do total rebounds per game, I can take the total rebounds variable, the games variable, divide them, hit enter, and make a new variable. And you can do that with any mathematical operation.